Hello everyone and welcome to this video on the Python programming language and machine learning. So in this video, I will attempt to predict the price of Coca-Cola stock using machine learning algorithms. Now before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell button. Now, the material in this video is purely educational and should not be taken as professional investment advice, so invest at your own discretion. All right, so let's go ahead and begin. So right now I'm on Google's website. It's called colab.research.google.com, and it makes it easy to start programming in Python. So all you have to do is go to this website and log in using your Google account and get started writing your Python code. So to get started writing this code, you're going to want to click on File and then New Notebook, and a new tab will open up for you. And this is where we will begin our program. So the first thing that I'm going to do is type in a description about the program. So this program predicts the price of Coca-Cola, or KO is the stock symbol for Coca-Cola, stock for a specific day. And we're going to do this using machine learning algorithms. So I'm going to basically build 3 models based off of machine learning algorithms. All right. So let's go ahead and create a new cell by clicking that code button in the top left. And in this cell, I'm going to import the libraries that I plan on using throughout the program. So from sklearn.svm, I'm going to import svr. Next, I'm going to import numpy as np, and I'm going to import pandas as pd, and I'm going to import matplotlib.pyplot as, or pyplot as plt, and then I'm going to give the plot a style. So I'm going to type plt.style.use, and I'm going to use the 538 style. So let's go ahead and run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. Okay, so no errors there. Let's go ahead and create a new cell. And in this cell, I want to load the data. So from google.colab, I'm going to import files, and then I'm just going to type files.upload to upload the file. So let's go ahead and run this cell and click on choose files. And I'm going to upload this ko_stock.csv file, and it's done. Let's go ahead and create a new cell, and let's store the data. All right, so I'm going to create a variable called df and set it equal to pd.read_csv, and I'm going to input the name of the file that was just uploaded. So I'm just going to highlight it and copy it using Control C, and then come down here and paste it using Control V. And then I want to show the data. So I'm just going to type df here, and let's run this. Okay, so now we can see that this data set contains a date column, an open price column, a high price column, a low price column, a close column, an adjusted close column, and volume column. And the date range is from October 1st, 2020 to October 30th, 2020. Now, the idea here is to basically train these 3 models that I'm going to create in this video to try and predict the price of a stock, or more specifically, the price of Coca-Cola stock. I'm going to train it on this data set except for that last row of data. And we're going to use this last row of data to see how well the model did, just to kind of test it a little bit. And I'm going to try to predict the adjusted close price here. Okay. So let me make sure this is the adjusted close price column. It is. Yes. All right. So let's go ahead and create a new cell. And in this cell, I want to show the last row of data. Well, I want to show and store. So I want to show and store the last row of data. So this is going to be the value that we want to print, right? Or that last row contains the value that we want to predict. So I'm going to create a variable called actual_price and set it equal to that last row of data. So that's just df.tell. All right, and we only want to show one row. So next, let's go ahead and show the data, actual underscore price. And now we should just see that last row of data. Okay. And again, I just want to predict that adjusted close price here from the models. All right. So we're not going to show the model this data right here. We're going to see if the models can predict this price by itself. All right. So let's create a new cell. And now in this cell, I want to prepare the data for training the models. So I'm going to get all of the data except the last row. Again, that last row will be the data that we test on, right? So just set df equal to df.head, and I want all of the data except for that last row, so -1. And then let's go ahead and show the data set, df. All right, so let's run this. And now we can see we have basically all of the data we had before except for that last row of data. Now it ends on October 29th, 2020 instead of the 30th like it did, the 30th like it did up here. Okay, so let's go ahead and create a new cell. And now in this cell, I'm going to create empty lists. And these lists will store the independent data and the dependent data. So I'm going to create a variable called days, and I'm going to set it equal to list. And then I'm going to create another variable called adjusted underscore close underscore prices and set it equal to an empty list as well. Okay, so let's go ahead and run this cell, and let's create a new cell. Now in this cell, I'm going to get only the date and the adjusted close prices. So I want to get the dates and the adjusted close prices. All right, so I'm going to create two variables. One will be called df underscore days, and I'm going to set it equal to df dot lock. And I want to get all of the rows from the data set, but I want all the rows from the column date. And then I'm going to create another variable called df underscore adjusted underscore close. And I'm going to set this equal to df dot lock. And I want all of the rows from this data set from the column adjusted close. Okay, so let's go ahead and run that. And let's create a new cell. Now in this cell, I want to create the independent data set, which will be the dates. And I want to create the dependent data set, which will be the adjusted close price or adjusted close prices. Okay, so for day in df underscore days, I'm going to append to my days list. So days dot append. I want to append only the day from the date. So that's day dot split. And I want to split on that dash on the date. And then I want the value at index 2. Okay. And I also want to make this an integer. So I'm going to cast it to be an int. Okay. And I want this to be a list. So let's go ahead and add the square brackets around it. Okay. So next I want to get the adjusted close prices. So for adjusted underscore close underscore price in df underscore adjusted close, I want to append to my adjusted close prices list. So I'm going to type adjusted close prices dot append, and I'm going to append the adjusted underscore close underscore price. And then I want this to be a float, so I'm going to cast it as a float, and that should do it. So let's go ahead and run this. All right, and let's create a new cell. And now I have created my two data sets. So let's go ahead and show the days. So I'm just going to type days here, and let's run this. And now we can see that we have the days. So we have 1 to 29 here. Of course, they're not all sequential, right? Because the stock market isn't open every day. So we're going to be missing a few days. All right, so let's go ahead and create a new cell. And let's also show the adjusted close prices. So I could just type adjusted underscore close underscore prices, and let's run that. And so now we can see the adjusted close prices here for each day. And let's create a new cell. And now I can create 3 models to make our predictions. So I will create a variable called len underscore SVR, and I'm going to set this equal to SVR, and I'm going to give it a kernel equal to linear, and then I'm going to set the C value equal to 1000.0, and then I'm going to train the model. So I'm just going to type len underscore SVR dot fit, and I'm going to train it on the days and the adjusted close prices. Okay, so this is the linear model that I'm creating. Let's go ahead and highlight this, copy using Control C, and then paste it about 2 more times using Control V, and then just make a few changes for our other 2 models. So let's call this poly underscore SVR because I'm going to be using a poly kernel, and C will remain the same, and I'm going to give it a degree equal to 2. And then I want to change this len value here to poly as well, and that should do it. So next I'm going to create an SVR model using an RBF kernel. So I'm going to make this RBF underscore SVR, and the kernel will be RBF, and the C value will stay the same. And this time I'm going to have a gamma value equal to 0.85, and then I want to change this variable here to RBF to train that model. Okay, so let's go ahead and run this. All right, looks like it's done. Let's create a new cell. And in this cell, I want to plot the models. So I need to create a figure. So just type plt.figure, and then I want to give the figure a figure size. So I'm going to set the figure size equal to 16 by 8. And then I want to plot the original data point. So just type plt.scatter and input days, and then the adjusted close prices. And I will give this a color. The color will be black, and a label equal to the actual data. And then I want to plot the models. So I'm going to type plt.plot and input days, and then I want to put in the predicted values of the models. So that's RBF underscore SVR dot predict, and then I'm going to input days there. I'm going to give this a color, so I'm going to set the color equal to green, and then I want to give this a label. So the label will be RBF underscore model, or forget the underscore, just RBF model. So next I'm going to go ahead and highlight this, copy using Control C, and then paste it about 2 more times because the other models will be very, very similar. So instead of RBF here, it will be poly. And instead of green, I'm going to choose orange. And this will be polynomial model. And then I'm going to change the variable here to len underscore SVR. And the color here will be blue. And the label will be linear model. Okay. So next I'm going to give the x-axis a label. So just type plt.x label, and it will be the days. And then I want to give the y-axis a label. So just type plt.y label, and it will be the adjusted close price. I'll put a nice little $sign there. And then I want to give this plot a legend, and I want to show the plot. So just type plt.show. Okay, so let's go ahead and run this. And just like that, we can see our three models. So again, the black dots are the actual data points. So that means that these are the actual values of Coca-Cola stock for the given day, right? So if we look on day 5, we can see that the adjusted close price was $49. Okay, and the model that seems to have done the best in this case is the RBF model. So you can see that it's matching the data points pretty well. Not exactly, but pretty well. Okay, so let's go ahead and create a new cell. And in this cell, I want to show the predicted price for the given day, or for a given day. All right, so let's create a variable called day and set it equal to 30. And actually, I'm going to make this the given day because I'm only interested in day 30, right? So if we go back up to the original data set, we can see that the last day was day 30. And again, we want to see if the model can predict this adjusted close price for day 30, if any of the models can. All right, so I want to know what the price of Coca-Cola stock will be for day 30. And I need this to be within, I need it to be a list within a list. All right, so let's go ahead and print these values. So first I want to print the RBF SVR predicted model or predicted price. So I'm gonna put a little colon there and then put RBF underscore SVR dot predict, and then I'm going to input the day just like that. And I'm going to highlight this and copy using Control C and then paste it 2 more times using Control V, and then just change a few things. So I'm going to change this to linear. So I need to change this here to lin. And then I'm going to change this here to be polynomial. And I'm going to change this to poly. Okay, so let's go ahead and run this. Okay, and now we get back the predicted values. So the RBF SVR predicted about 48.94. The linear model predicted 49.92. And the polynomial model predicted 49.34. So let's create a new cell and let's show the actual price. So here I'm going to print the actual price. And the actual price we stored in the variable actual underscore price. And I want the adjusted close price. So if I run this, I get back not exactly what I wanted. So I'm just going to add 21 here. And let's run this, and I should only get back the price now. So now the actual price is 47.6861. Yeah, 47.6861. So the model that seems to be the closest is the RBF SVR model. And it looks like it's off by about 1.2 something. So that's not bad. It's very, very close. And I really like that. Okay. But again, many mathematicians and many um, different people and and many different stockholders have tried to predict the values of stock, but it's really difficult to predict the next day's price of a stock. Let's say, for example, so take these models with a grain of salt. All right. And again, this is not investment advice. I just thought this was very, very interesting, and it was something that I could show to all of you. So thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. If you would like to become a supporter of this channel, I will leave a link in the description below. Thanks again for watching, and I hope you all have a great day. See you in the next video.